Okay. So we have to do. You have to do your condensations. Why? Because if you don't, and you just come up with some, some answer or some version of an answer, if it's all right, maybe you'll get credit. But if it's not, then you won't get any partial credit. So you need to do your condensations. So my first one, I would do something that looks like this, because I'm going to look at this and I'm going to add up everything I can. I can add this, I can add this, and I can add that. Do you get it? You see what I'm saying? I can't combine this to this yet. So what I will do is I will draw this out like this. And this becomes r over 2. This becomes r over 3. This becomes 2r, and that's r. Take a look at what I've written. Make sure that you can answer the why question. All right. Once I've done that, then I do another condensation, where I put that together, right? And I'm going to get like this. This is still r over 2. This is still r over 3. But what does this become? Well, it becomes 1 over 2r plus 1 over r. Let me do it up here. 1 over 2r plus 1 over r equals 1 over r total. So this becomes 2 over 2r. So r total is r over 3. Does that make sense to you? Is that right? No, that's not right. It's 3 halves. Good gravy. I'm glad it doesn't make sense to you because it's wrong. 3 over 2r, which becomes 2r over 3.
Wait, 3 halves.
Right?
No. Is it a 3 over 2?
3 over 2.
3 over 2.
3 over 2. 3 over 2r. It's 3 over 2r, but you have to flip it, so it becomes 2r over 3. 2/3 r. There. 2/3 r should make some sense. I promise you that's correct. So this becomes... Yeah, see? Yeah, exactly. I would have had to lie. I would have been a liar. Right? And then I combine all these 3 things into one resistor. And when I add them up, I get, so r over 2, r over 3, and 2/3 r. R over 3, 1/3 r, and 2/3 r gives me r, right? And then r over 2, so that gives me, does that give me 3 halves r? 3 halves r, and that gives me 9 ohms.
So we have points just for doing that, right?
Yep. And then this is 18 volts, right? So what will happen here is you'll get points for showing knowledge. For example, did you know that this gets divided by 2? Did you know that 6 and 6 is going to come out to be 3? Did you know that 6, 6, and 6 comes out to be, mark up the devil. No, just kidding. If you do know that 6, 6, and 6 comes out to be 2 ohms instead of the 3 ohms from here. And did you know that these 2 come out to be 12? Get it? So did you do those things?
On our test, we're going to have a diagram.
Yeah, there will be a diagram, but you'll have to do your own condensations. Now, moving to the second part. We have this circuit. It's nice and long, it's and short, okay? The second one, I'm supposed to calculate what? The powers? Okay. The total power is actually pretty easy. Actually, you know, maybe I'll just do it on here. Let's do the powers in yellow. What is the equation for power? P equals IV. It's also I squared R, and it's also V squared over R. So pick one. We have V, we have R. So V squared over R should be something like 36 watts. You could also say the current is 2 amps. So then I can use I squared R, which would be 2 squared, which is 4 times 9, which also comes out to be 36. So the total power is 36. So the power total is 36 watts. Now we have to figure out what each of these things are. The easiest way to do that is by current. The current coming out of the battery is 2 amps. Does that make sense to you? Right? 9 ohms, 18 volts, 2 amps. When we hit this first junction, which way is the current going to go? Both ways. Is there any reason one would have more current than the other? No. So this is going to be 1 amp. This is going to be 1 amp. And then, remember, one of the equations was I squared R. So then, that means I squared times R gives me 6 watts and 6 watts. I'm also going to do voltage. You did not have to do that for the question, but I'll do it just so we can see. V equals IR, so that gives me 6 volts here and 6 volts there. Now, let's do the current again. How many amps is right here coming through this wire? 2 amps. Is everybody okay with that? Okay, because what was 2 split to 1, 1 had to come back to 2. Now what happens here? Into 3 even pieces. 1/3, 1/3, 1/3. Is that correct? Okay, 1/3 of what?
2.
Very good. Did you hear what you just said? It's 1/3 of 2. It's not 1/3 of 1. So you don't do 1/3 amp, 1/3 amp, 1/3 amp. You do 2/3 amps, 2/3 amp, 2/3 of an amp. Okay, now I have I and I have R. So V is IR, which means in terms of voltage, I can say 6 times 2/3 is going to be 4 volts. 4 volts, 4 volts. Again, did you need to do volts on your homework? No, I'm just showing this to you so you can see what we're doing. Now we can do current, we can do power, and it's just IV. What's 2/3 that? That's going to be like 8/3 of a watt. 8/3 of a watt and 8/3 of a watt for each channel. We continue with our with our current analysis. What is going to be true here? So I get half of the current here, half of the current here, right? Ah, who said no? Very nice. Sophia, did you say no? Okay. Okay, so why? Why is it no? Do you see that there is twice? Sorry, go ahead. Do you see that? Okay, I even like that. Good. I was going to say something that's better. This side is series, and therefore it has twice the resistance of this side. Do you see that? Think about this in terms of hallways. Remember, wires are hallways. Current charges are the students. So the students flow down the hallways. If there are 2 hallways that have the same, they're exactly identical, is there any reason that there should be more students walking down one hallway than the other? No. Thank you. However, if we had 2 other hallways somewhere else in the school, and one of them had a bunch of desks piled up in it, does it make sense to you that the one with the desks would have less traffic than the other one? Right? It's a matter of there's not enough room for people to go through. Now, if this has twice the resistance, and remember, when we say resistance, we're talking about resistance to what? Resistance to what? What flows through the circuit? Current. So it's resistance to current, right? That's what it means. So if this has twice the resistance, what fraction of the current should it have? Yeah, it's going to have, does it make sense to you that this is going to have half the current of this? I mean, whatever this has, this will have twice, whatever this has, this will have twice as much current. Okay, now how does this work? We can do something, I don't know, mathematical like, I'll just do this. I'll say, let's say that this is I total, and then we'll say, and that's going to equal, let's call this 1 and call this 2. So we're going to have I1 plus I2. Does that make sense to you? These 2 currents have to add up to be that one. Now, what do we know? We know that this is 1, remember, I1, 2 times I1 should equal I2. Right? The current in I2 should be twice as big as that one because the resistance is half as much. And if resistance is talking about resistance to current. If you have double the resistance to current, you'll have half as much current. So then from this, we can say I total is equal to I1 plus 2I1, and therefore I1 is equal to I total over 3. And so what is I total? 2 amps, right? So then we get this, once again, is 2/3 amps, just like these, and this becomes 4/3 amps. And we can go ahead and go with our little voltage thing as well. What's 4/3? So V is IR, so what's 4/3 of 6? Yeah, 8. 8 volts. And then what's 2/3 of 6? So you can see, whether you go left side, whether you go right side, you're still going to use up 8 volts. So we come out of the battery with 18 volts. We lose 6. That leaves us 12 volts right here. Anyway we go, we lose 4. That leaves us 8 volts right there. Which means how much do we have to lose? 8 when we go back to the battery. Do you see that's the quick way to do it without doing this? You want to do this the sneaky way? Do it this way. Say, oh look, I have 8 volts to lose, and if I go this way, I lose them all right there. Bingo, 8 volts. I got 8 volts to lose. I go down this way, there's only 2 resistors. They're identical, so I must lose 4 at each. And you don't have to mess with this crap. But, gotta explain it anyways. So either way will work. Okay, and of course we can put on our little power hat again and say P is like IV, so this gives us 32 over 3 watts, and then over here this gives us 8 over 3 watts and 8 over 3 watts. So then, which one's the brightest? Brightness relates to what? Yeah, to power, to watts. And which one has the highest watts? That's number 1. We have a winner. And do you see that this, and this is all the same? So that's number 1. These two are number 2. And then all of these are number 3. Oh, just kidding. Including those. Those are all tied for 3rd. They're all the same dimness. Or brightness, depending on how you look at the situation. So that's 1 and 2, and 3. Again, this is being recorded, so if you need it, it's online. Now we do this. Okay, and these are all 6 microfarads. Or whatever. If you use farads, it doesn't matter. What did I say? Was it micro? Okay, cool. So what we're going to do is we have to remember first and foremost that when you deal with capacitors, what do you have to do? Yeah, it's the opposite, right? Series is inverse and parallel is just add. So when I go to my first condensation, do you see that I can add this very easily, and this with some small difficulty? It's the same logic as before we added those same 3 things first, but we just change how we add them. So here, it becomes easier to add most of it. So then this comes together to become 12 microfarads. This comes together to become 18 microfarads. That's still 6, but now this one is 3. Because it's inverse, right? And of course, that's 1 over 6 plus 1 over 6 equals 1 over c. So c is 6 over 2. Okay, so now we can have these two. That's easy. And we get this. And that's 12 microfarads, 18 microfarads, and 9 microfarads. And now we have to add 12, 18, and 9. So what's our least common denominator? Yeah, 36. So we're looking for this. So we're going to go 1 over 12 plus 1 over 18 plus 1 over 9 is equal to 1 over c total. And that's going to be 3 36 plus 2 36 plus 4 36, which gives us 9 36. And that gives us a total capacitance of 4 microfarads. So that thing is 4 microfarads. This is 18 volts. Now, we're supposed to come up with a charge on every capacitor, right? Okay. What is the equation for that? C is Q over V. Therefore, Q is C times V. And that means all of them together, the total charge in this circuit at any one capacitor is, or every one set of capacitors is 72 microcoulombs of charge. Because it's 4 microfarads times 18 volts. So that means when I stand at the battery and look down the hallway, I will see those 2 capacitors down here. Does this make sense? You know what I'm saying? When I stand at the battery and look down the hallway, I can see the 2 capacitors. And imagine that charge is what? Current was like what in my analogy of the school? Yeah, current is students, because that's the charges. So guess what the charges are? They're students, right? Charges are students. Charges are people. They have mass, they have identity, you can't get rid of it. So when you look from the battery down the hall, you see 72 people, right? Because you see them on those 2 capacitors. So imagine that each one of these things is kind of like a window. Because people can't walk through it, right? It's like big sheets of glass. And then we all walk and boom. So they're standing there looking. And so what happens is here, when you look this way, you see 72 people on these 2 windows. Is there any reason that there would be more on one than the other? No. And so you will see 36 microcoulombs there, 36 microcoulomb, whoops, just kidding, microcoulombs there of charge. Because you see those 36 people looking through the glass. Now, if we're looking and we see their backs, right, the plus, and you're standing on the other side of the glass, you look this way, what are you going to see? Yeah, you're going to see like their faces, right? The other side. And the other side is negative. I guess it depends on which side you want to look at. Adjust this analogy for your personal proclivities. Okay, so at any point in this circuit, at any point in the main part of the circuit, when you look one way or the other way, you have to see 72 people. Whether you see their front or their back, just depends on what direction. If I stand here and I look this way, do you see I'm seeing the faces of 72 people? When I look the other way, what should I see? Yeah, I should still see 72 people, but now I'm going to, and if there's 72 people with 3 windows, how many people is that per window? 36 times 3 would make 108. 12 times 3 would make 36. It's 24. Do you see it? It's 72. If I stand at the battery and look down, how many people do I see? 72. If I stand over here and look up, I see 72. If I stand here and look over, I see 72. If I stand over here, I have to see the same thing. So once again, negative 24, negative 24, negative 24. Now, here's the difficult one. If we take a step back, do you see that these two add up to be a smaller capacitance than the single one? In fact, this is half. If the window is half as big, how many people should you have as opposed to the other one? Yes, does that make sense? If the window is half as big, then you should only be able to fit half as many people. Which means 2/3 of the people need to be on the other window, and 1/3 needs to be over here. So that's going to give me 48 microcoulombs of charge there, and 24 microcoulombs there. And then this is going to be, this will be negative 24, this is 24, this is negative 24, and this is negative 48. And if you take a look at that, you'll see that the negative sides are connected to the negative side of the battery. And then opposite a negative side is always a positive. Well, this positive is connected to that negative. And that negative opposite of that is a positive. Positive 48, positive 24, that's 72. So then I go to, every time I'm on the main hallway, looking down the hallway, I see 72 people. Now, does it make sense to you that if I walk down this side hallway and look, I'm only going to see 24 people? Right? But it's still the same. And Wes is like, what's subject? You're talking about people. This is about a week or so. So what I was doing is I was trying to use the analogy of like in resistors, we use the analogy of people walking down the hallway as current. Well, in a capacitor, those people stop because they're blocked. So imagine if there were these windows across the hallway. And then that's why they stand there, because they can't get across, so they just stand there. Exactly.
So we need to write the names too.
I never had to ask anybody to go to prom.
They ask you?
Wait, you didn't ask anybody?
They asked you?
No. It was like I was always going out with somebody.
So it's just like,
Yeah.
Wait, so like
When I was a sophomore, there was no, like sophomores couldn't go to prom unless you were asked. I'm not gonna get asked by a senior, junior girl, that's not gonna happen. And so, because I was new to the school anyway. So then, but by the time I was a junior and a senior, I already had a girlfriend. So then I just went with them.
wait, you went twice?
Yeah.
Well, even if you're with a girl, shouldn't you still ask them first? You just said to them, okay, we're going or something?
Mike, you wanna go?
I don't remember. I think it's, I don't remember. I never had to do anything to impress her in terms of asking her to go. So.
yeah, so I feel like that's like the standard now. The guy has to do something.
Yeah, some mind-numbingly.
Yeah, it's like you're
See, like, I have no problem with that. That's cute. That's sort of fun. That I personally, if I had a daughter, I would say you should definitely consider yourself like a prized treasure sort of thing, and that your company to the prom is a gift, and it will only be given to those who show themselves worthy. That's what I would hope that my daughter would believe herself to be that way. Exactly, that's what it should be like. She should be like, you have to prove to me that you are worthy of my attention and going.
Wow.
Seriously, I would hope my daughter would be that kind of a person. And that way she would automatically just weed out half of the asswipes who would want to go out with her.
Why?
Like any guy who would come up to with her and some sort of swagger and be like, I'm gonna do you a favor and you're gonna go to prom with me, she'd be like, yeah, right. Yeah. You might want to rethink that position. But you know what I mean? Like I would hope that a lot of the problems that are in relationships come from, yeah. Well, I mean, okay, they're not the cause of girls. It's. I think a lot of the problems that girls have come from the fact that they don't sort of stand up for themselves and expect good behavior and expect to be treated special. So, I would hope that my daughter would be like my wife, in that she would be like, okay, loser, no. Yeah, and not have any, and not be like, well, you know, he's a nice guy. No. I mean, you're doing a guy a favor if you don't like him at all, to not go out with him. like just to say no. Because like, I don't know, maybe the other guys are different, but like me as a guy when I was in high school, it's like if I liked a girl and she gave me any attention at all, I automatically assumed, oh, maybe there's hope, maybe she likes me. Right? I don't think girls do that. Girls will give attention to people just because they feel like it, or because they want something, or because.
Maybe there is hope though. You don't believe in yourself at all.
See, no, like I think a girl could call a guy and have absolutely no interest in dating them. But if a guy calls a girl, unless he wants something, like I want the homework, or you know, whatever. If a guy calls a girl and just starts talking, how are you doing? Boom, no, he's trying to go home with you. Because if a guy wasn't interested in going out with a girl, he wouldn't even talk to her.
That is true.
He'd just be like, oh, you sit next to me in physics? Okay, whatever. Yeah, I mean, I hate to say that. Now, I have to say, I don't know how the guy thing works out with guy-guy relationships.
What?
Huh?
Like, I don't know how the gay relationship thing works at all. I have no insight into that. So that would be interesting to sit down with like, you know, some gay men or something and have conversations about how their relationships work out.
Serious, because like you can analyze like
Yeah.
guy-girl relationships, so like almost.
Yeah, I can analyze guy-girls, but I don't know how to analyze, you know, does one of them act like the girl and one of them acts like a guy, or I don't know.
So you're saying that when a girl calls a guy, it doesn't really matter?
Yes, it doesn't really matter. It could, but it doesn't mean really.
Really?
Like if a girl calls a guy for no reason, she could just be lonely or bored or something. Yeah. But if a guy calls a girl for no reason, in my experience, like 99 times out of 100, it's because he's interested in her. At least that's why I think you never hear. How many times in your life have you ever heard of a guy telling a girl, "No, let's just be friends"? Are you kidding me? Most guys will make out with a girl for no reason at all. It's like, who are you? Blah, 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 blah. I mean, they require nothing. They require no emotional connection, nothing. But then I feel like what happens, like I feel like the reason that girls allow themselves to be put in that situation is they put stuff in their mind into the guy that may or may not really exist. You know, like they've been looking at this guy, they kind of like him, they think about him. Oh, I bet he's really. They see things that make him look really nice. Like the girl who went out with me when I was a senior, she fell in love with me because I threatened to kick her boyfriend's ass.
The logic behind it.
Yeah, I know, right? Well, I mean, it was because she had bruises on her arm, and she was crying. I said, "What's wrong?" And she said, she wouldn't say. And then finally, we got out of there. Her boyfriend like pushed her around in the parking lot, and then so I threatened to hurt him very badly. And then of course they broke up that next day.
How did she find out?
I don't know how she found out. I mean, I didn't tell her. Hey, hurt me.
No,
Well,
you
What did I
did.
do? No, I didn't tell her. But because like her boyfriend, she was a sophomore as a senior, and her boyfriend was on the JV football team. So after practice, I went up and I was talking to him, and then he's like, "Oh, I've never done that," and I'm like, and I got really mad because he was, you know, like a prick. Like, who beats up on a girl? Seriously. So then I punched his locker, and I caved in his locker. But it wasn't that surprising because they're like the PE lockers where they're like this. You know what I mean? They're not like solid steel, so it wasn't that big of a deal. And I was wearing these big heavy gloves. So I punched it in. I'm like, if you hurt her again, I will kill you. And then that was it. They broke up that day.
Who broke up with
I don't know. But
Wait,
then
so was there-
somehow she got wind of the fact that it was because of me. And I didn't like her at all. It's just that bothered me that somebody would do that.
And why'd you call him?
Well, see, like first she asked me if I just wanted to go to like the girl ask guy formal. Because like there was,
What's
at our
the
school there were two formals. One was prom, which is, you know, classic whatever. And then the other one was
Sadie.
winter formal, which you guys, we have winter formal, right? Except winter formal was like Sadie's, was like girl ask guy formal.
That's weird.
Yeah, I mean, it doesn't really mean anything nowadays, right? Because do you have two more formals where it's like guy ask guy formal? The girl ask girl formal, or what? I don't know. It's too confusing now. So it's just whatever, winter formal, prom. But whatever. This is back in the old days. But
That's why it was really cold, girl ask guy formal.
no, it was just called winter formal. But it was like the tradition was girl ask guy. So, and I mean, I'm not trying to put some sort of value judgment like, oh, that's what this girl should have. I'm just saying that's how it was. But, and then she asked me to that, and then,
Yes, meet up.
yeah, so. I was an idiot, basically, and because I was an idiot, then I went out with her for 4 years.
4 years?
Yes. I was such a moron. Oh my god.
How did that last?
She went on vacation with her parents, and then came back and said, "Oh look, I got a diamond. Do you want to buy it?" And I'm like, "What?" Like, so yeah, like I even bought her a diamond to marry her.
Why?
Yeah. Well, I don't know, because I was dumb.
Well, you bought her a diamond to marry her?
Yeah. So I was dumb. I was an
How does
idiot.
that make
Huh?
sense?
You regret the relationship?
Oh, totally. It was such a waste of my time. I could have had so much more fun hanging out with all of my guy friends in high school, or just, you know, just going out for fun with other girls and getting to know them and learning how to interact. It would have been so much better.
Business
Oh,
to you?
God. Hang on.
Business
What?
to you?
Well, the thing is, like, I found out later, she cheated on me.
That sucks.
It's like I'd go off to school, and then she had a boyfriend back at home.
Terrible.
Yeah, it's really funny. And it's really funny, too, because, like, fast forward, I told you this already.
No.
I had to have told you this.
About what?
I did, right?
Oh yeah, you meet them.
Part
Yeah,
of it.
yeah. I met him, and when
Oh,
I
yeah,
found
you
out
told
that
me.
he went to La Quinta in high school, I tried to like strike up all these conversations, talk to him, and he acted really weird. And he's like kind of nervous, and I'm like, wow, I must just be really, I don't know, does my breath stink or something? 'Cause he's acting really weird. And then many years later, now I know why he was acting so weird, because he was the guy that my ex-girlfriend cheated on me with.
Did he know?
Yeah,
You
totally.
didn't care?
I guess not. Yeah. He was in her same grade, and he was totally in love with her since they were in like 6th grade. So, I guess.
That's nuts.
Yeah.
Would you be okay with it?
Would I be okay? I mean, I would have just preferred for her to say, you know, I want to go out with somebody else. I'd be like, okay. I mean, she broke up with me after 4 years.
No, I'm saying, would you be okay if you were in his position? Would you be okay with that?
Hell no, I wouldn't go out with like a girl with a boyfriend. What kind of a prick does that?
So were you heartbroken?
No.
Oh really?
When she broke up with me, I was pissed because I had wasted 4 years. I was walking away from her apartment going like, God, what an idiot I am. I wasted 4 years with her. And I was like, the first thing, it's like, I remember, it was like kind of sunny, whatever, and I went to step off the curb, and I went, I wonder what Michelle's phone number is. Michelle's my wife now. So I was like,
Are you serious?
yeah. And then I said, you know what? This is stupid. Like, I've been going out with girls all this time, wasting my energy on relationships. I'm not going to do it for like, I don't know, like a couple of months or something. I think I said, I don't know. I think at first I was going to, I'm not going to date anyone for a year. And then like the more I talked to Michelle, the more I started liking her. So,
Wait. So what's that?
because like my girlfriend broke up with me in December. And then I'm not the kind of guy who can go through life without female companionship. So I'm going to find somebody. But I'm not going to jump at the first girl that I thought about, right? Because like up until that point, the girls that I dated pretty much like fell in my lap. It was like, you know, they asked. So, I mean, that's not because I'm so cool. It's because I'm an idiot. I mean, you shouldn't do that. You shouldn't date a girl who asks you out specifically.
What?
Not because she's asking you out, that's fine. I mean, a girl can ask a guy out, but I think it should be like, you shouldn't date somebody unless you feel like you would have asked them out. Do you know what I mean? So if a girl comes up and says, oh, I really like you, let's do something, don't automatically say yes. You know, say, wait a minute. Do I appreciate the good things about her? Am I interested in her? Do I find her attractive? If yes, then go out. You know what I mean? I just went, oh, okay, I like girls.
Wait, so did you plan on marrying your senior girlfriend?
Yeah, but yeah, I was.
So if she didn't cheat on you, do you think you would have?
Well, I didn't know she cheated on me then. She just, like, I was at UCLA, she came to UCLA, I was in a Christian fraternity. She joined like the Little Sisters of the fraternity, and then didn't like it. So then she joined like a regular sorority and began partying, and then realized that there's no way she could remain faithful to me and continue to party. So I don't know, I guess she got a conscience in college or something. And then, well, maybe because we're at the same place, but then she said, okay, I want to go out with my friends and do this stuff, so we need to break up. And it's not like I argued, I went, okay.
Wait, so you didn't really care?
No, no, like, oh my God, I tried to break up with her, like,
You tried?
in like June or July of my senior year. I tried to, and she flipped out, like flipped out. Like I'm in her room and I'm like, you know what? I'm going off to college, you know, Wah! Screaming. Wah! I'm like, Jesus Christ, what is wrong? I mean, you know, God, what? Calm down. And then like, I started to leave the house, and then her mom intercepts me, and her mom's like, "Wah! Why do you hate us?" Wah! I'm like, what the hell? And then like I'm around the mom and I'm heading for the door, and the little sister, "Wah!"
Wait, why?
And I'm like, jeez.
Wait.
I don't, oh my God, I can't live. I'm like, oh my God, come on.
Wait, they knew about your relationship and
Well, yeah, I mean, we've been going out, and I guess her mom really liked me, and her sister, I don't know, it was just crazy, it was psychotic. And I'm like, fine, just kidding, and everyone's okay.
Wow.
I mean, that should have just been like, okay, now I'm gonna get out of the house, close the door, and run like hell, and never gonna come back.
I'm just kidding.
I don't stay on the curb, turn around my car. Ha! Just kidding on me. Just kidding.
that's crazy.
Yeah, it was madness.
So like, do you think guys marry any girls?
No.